Hey, how's it going? Hey, it's day two. We're doing Advent of Code day two. I've got a different shirt on because it's yesterday's tomorrow. I still got my water, and we're gonna write some stuff in Elm today. Very exciting time to be alive. Let's pick up where we left off yesterday. We did everything in the browser. We didn't have to install anything. So this was the puzzle we left off with yesterday. I'm just gonna like clear this out, and then we're gonna open up the new day two puzzle here at adventofcode.com, and yeah, we'll get started. So I'm just going to clear some of this stuff out. Delete. Answer. So day by day, the puzzles that we're going to solve are going to change, so there's no need to like keep old stuff around, I don't think. And let's just see if we can get 1, 2, 3 on the screen. Awesome. Okay, cool. Let's dive into problem 2. Day 2, dive. Well, that was kind of freaky. Now you need to figure out how to pilot this thing. This thing is like a sled or something. I kind of forgot what we were doing. It seems like the submarine can take a series of commands like forward 1, down 2, or up 3. Forward X increases the horizontal position by X units. Down X increases the depth by X units. Up X decreases the depth by X units. Note that since you're in a submarine, up and down affect your depth. They have the opposite result of what you might expect. Decreasing depth. Up, and that makes sense. Okay. The submarine seems to already have a planned course, which is our puzzle input. You should probably figure out where it's going. For example, if we get forward 5, down 5, if we get all that stuff, what that means is our horizontal position and depth both start at 0. The steps above would then modify them as follows. So forward 5, it'll add 5 to our horizontal. Down 5 will add 5 to our depth, resulting in a value of 5. Okay. 8 increases it to 13. Okay, so we're just kind of like moving on a 2D grid. After you follow these instructions, you'll have a horizontal position of 15 and a depth of 10. Multiplying these together produce 150. So it wants us to calculate the horizontal position and depth that we'll have after we follow this course. And what do you get if you multiply those two numbers together? Okay, let's take a look. So we're going to start this puzzle like we started the last one. I'm going to give this a new name before I forget. So I'm using Ellie here. Ellie's a way for us to do our Elm stuff in the browser without having to install anything. So if you missed yesterday's video, we did day 1. I'll have a link to that in the description. But today's video, we're going to be doing day 2 and get some more stars. Very exciting. Okay, so we're going to start with this, and I'm just going to see if we can get this printing on the screen. Okay, cool. So we've compiled that. This is our input. What we want to do is we're going to break this apart by lines. So we're going to use the pipelines that we used yesterday. This is us just calling the lines function on our input, which will split things into a list of strings. Cool. And then what we're going to do is we are going to filter out, basically, we're going to map them to like a bunch of commands. So yesterday we learned about the difference between filter map and then filter map. But just a quick refresher, what filter map is going to do is it's going to go through each item in the list. It's going to run a function that can either like succeed or fail, and it's only going to keep the things that succeed. So our function we're going to write is going to be like toCommand. So a command is something we're about to make up. So toCommand is going to take a string. So that string could just be this empty string. It could be forward 5. It could be anything. It could just be the word banana. Basically, a string is just any text that we could get from this puzzle input. And we're going to turn it into a command. But it might not always work, so we're going to do a maybe command. Cool. So we've got our string. And what we're going to do is we are going to basically define what a command is. So for now, I'm going to say nothing. But what I'm going to do is I'm going to define each of these. I'm going to define each of the commands that we saw in our practice problem. So for the problem, we had forward, we have down, we have up. And those are the three commands, and each of those is going to come with like an integer value for like how much to do that with. So with a custom type called command, we can do that. So we can say forward, that'll hold on to an integer. We can say up, that'll hold on to an integer, and down will hold on to an integer. Yesterday we saw with our admin of code problem that we could say like increase, decrease, no change. Today we're doing a similar thing, but this time we're actually able to hold on to like a value. So these are holding on to like the numbers as well as like the type of command it is, which is going to be neat. So what I'm going to do to implement toCommand is I'm going to take this string and I'm going to split it on spaces. And we're basically going to go through like a few possibilities. So if after we split it, if there's nothing left, if it's just like an empty list, we're gonna fail. So we're basically gonna say there's no command we can get from that. But if we get forward and then some number, and that we're going to say just forward, and then this is going to be like the parsed number if we can find it. So we'll come back to that. But keep in mind that all these things are going to be like just text, so we're going to have to like turn them into integers if they're going to work. So forward, up, we'll do that with up, and then down, we'll do that with down. So this is all going to be kind of the same code, but we're going to change how we like actually get this number. So what I'm going to do is I'm going to say, I'm just going to pass in the string, and I'm going to pretend there's a function called parse command, or I'm going to say parse number. So what parse number is going to take, it's going to be a function. You can see it's taking one of these. So this is a function of int toCommand. So we're going to say int toCommand is the first argument. So that can be forward, up, or down. It's going to take in a string, and it's going to return a maybe command. So basically, if it can parse that number value that we passed in, if it can parse this guy, we're good. Before I forget, I'm also going to do the nothing case here. So we can get rid of this too. So basically, if it's one of these patterns, we're going to be able to try to parse the number. If it's anything else, that's what this underscore means. We're going to just say nothing. We're going to fail to parse it. So toCommand is going to, from int is what we'll call that. I don't want to collide with this name. We've got string here, so that's going to be str. That's going to be like this is going to be the num string that we passed in here as the second argument. And what we're going to do is we're going to say, if I'm able to turn that num string into an integer, then we're going to do that. And we're going to basically call from int num, and we're gonna wrap that in adjust so that it fits the maybe. But if we're unable to turn our string into a number, we're just gonna do nothing. So let me format this. Let's compile and see where we're at. Okay, so we did a lot of code. Let's just kind of take a step back and understand what we did and like why we had to do all this weird number parsing stuff. So this is all like good input. It's like the happy path. So if I like had a typo here, like I was forgetting like the O, this would prevent our program from crashing. It's gonna keep this out because it's not a valid command. Basically, it doesn't match the forward, doesn't match the up, doesn't match the down. So that's what's gonna get us a nothing, and that's what's gonna filter that out. So anytime we get like an invalid line, it's just gonna automatically filter that out, and that's what the filter map's doing for us. And that's why we're using a nothing here. And then why did we do all this string.toInt stuff? Basically, if someone said, so notice we have a down 5 back in our results. If instead of down 5, if someone said like down chicken, we wouldn't be able to turn that into a number, so we should also filter that out. So you'll see that's now missing from our results. It's not in between those two commands. And that's basically hitting this branch where it's saying like, hey, we did get down, we called parse number, because down was found here. But then when we passed what we thought was a number into this function, it turned out that it wasn't able to turn it to an integer. And again, we're getting all these functions from like the Elm core library. So there's the toInt function. You can like search for it this way. And so if you get anything that's not an integer, it's just gonna return nothing back instead of like just and then a number. So that's kind of why we had to write all this code to handle these maybes and like deal with these weird values. But now that we did that, I'm gonna set this back to what it was. What was it? Down 5. Okay, I'm just gonna copy this again. So now we kind of have our parsed commands kind of out of the string format. So I'm just gonna call this parsed input for now, and we're gonna go back to the answer. So I'm just keeping track of that as a variable, and now parsed input is gonna be a list of these commands, and our answer itself is gonna be the parsed input again. So this is just me kind of taking all that work we did and putting it in a variable. So now that we have our parsed commands, I guess I could just call these commands, huh? That would be a better name. Cool. Now that we have our commands, what we want to do is we want to like have like some state that we're keeping track of, like it's initially at 0, 0, and then we're going to loop through each command and update that state as we go. So that's a really good use for a list fold L. So list.foldL is going to be like move, what are we moving? A submarine? Yeah, we're moving a submarine. So move submarine is going to be the function, and we'll get into implementing that. And what we're going to do is we're going to give it the starting coordinates. So x, 0, y, 0 is what it's going to be. I'm actually going to use a record here. So it's going to be a little bit clearer to see what we're talking about. Maybe I should use what they say in the puzzle. So depth, and this is going to be like horizontal position. Cool. So if it's going forward, up, and down, basically what's happening here is move submarine is going to be a function that's going to take in a command one at a time. It's going to take in the current, this is going to be like the initial submarine position. So I'm going to just give this variable here. Position, and I'm also going to give this a type alias so that it's easy to talk about it. So submarine position is going to be that type that we just kind of made below. So a submarine position is a horizontal position, which is an int, and a depth, which is an int. So these just help us read our code and keep track of what all these values are that we're passing through. But again, all these type annotations are totally optional. I just do it because it helps me keep track of what's going on. So for the move submarine function, we're going to take a command one at a time, and we're going to take like the basically the current submarine position. I'm just going to call that variable submarine. And then what we're going to do, actually, let me just rename that across the board just to be clear. So submarine, 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 submarine. This is the state of our submarine. So based on the command we get, we can switch and then like see the amount that we want to move forward, the amount we want to move up, the amount we want to move down. So in order to update our, basically if we get forward, we want to update our horizontal position to equal the submarine's current horizontal position plus whatever the amount was that came attached with the command. So for example, our first thing was forward 5. This would take the 0, 0 position and it would just add 5 to that. So as a result, this function would return like 5, 0. So we're going to keep doing that. Copy paste is a little dangerous. We'll see if this backfires. But when we move up, we're actually going to subtract the depth because we're moving up. It's going to be less steep. And I think that's what they were hinting at when it came to, like, that might be counterintuitive. Because subtracting when you increase something is kind of weird. But we are subtracting the depth. So if we go up, we want to subtract the amount, and when we go down, we want to add to the depth. So when we use a fold L on this, what we're doing is we're looping through all those commands one at a time, and we're updating the submarine position until hopefully we have something like this. So this is spitting out, we have a depth of 10 and a horizontal position of 15. And it looks like that's what we're seeing here. So the depth of 10 and the horizontal position of 15. So we're in good shape. I'm going to zoom in a little bit just in case that's hard for folks to read. I'm going to keep that zoomed out. Okay, great. So that, so far, so good. The final step they wanted us to do is they wanted us to basically multiply the submarine position. So we're going to make a simple function that does that. So that is going to take in our submarine position. I like keep going back and forth on what to call this. Maybe submarine position was okay. It just felt a little verbose, and I didn't want to keep typing that over and over again. So what that looks like is we're going to take the submarine again, and we're going to take the submarine's horizontal position and multiply that by the submarine's depth, so whatever they are. And I'm just copying these to save me some typing. I'm going to format that again, and we get 150. So looks like so far so good. All of our code seems to be doing what we expect. Let's take a look at the puzzle input, and let's see if we can solve the real puzzle. Got it. So I'm going to copy all this. I'm going to go up here into input, and I paste this here. When I compile, I get this crazy big number. This is that 1,427,868. So fingers crossed. Hey, okay, cool. All right, so we have 1 gold star. We're halfway done with today's puzzle. I'm not going to go on a crazy detour like I did last video. It's not going to happen. I have too much confidence in myself. So what we're going to do is we're going to continue to part 2. Again, the part 2 for these problems is usually like a twist on the initial thing. So what we solved in the first half of this video, it's going to be a little bit more interesting. Hopefully not too hard. Okay. So based on your calculations, the planned course doesn't seem to make any sense. You find the submarine manual and discover that the process is actually slightly more complicated. In addition to horizontal position and depth, you'll also need to track a third value, aim, which also starts at 0. The commands also mean something entirely different than you first thought. So down X increases your aim by X units. Up X decreases your aim by X units. Forward X does 2 things. It increases your horizontal position, and it increases the depth of your aim. Oh, it increases your depth by your aim multiplied by X. Okay, so it's kind of like tilting. So forward is like how much we're going like down. Again, note, since you're on a submarine, down and up do the opposite you might expect. So down means aiming in the positive direction. So that's what we were seeing earlier when we were adding that amount. So that's all good. Now the above example does something different. Okay, so when they do forward 5, it's going to set us to 5-0, which is cool. And then down 5 is going to add 5 to our aim, but it's not going to move us. So we're still going to be at 5-0. When we do forward 8, what's going to happen is we're going to go forward 8 more, so we'll be at 13. But we're also going to go down 5 times 8 because that's what our aim was set at. So we're going to be keeping track of a little bit more information than just the position. So I'm actually really glad we didn't call submarine position, because now we're going to have more data that's associated with it. So after all this is done with the same test data, we're going to hopefully see 900. So what I'm going to do is I'm going to, before we dive into this, I'm going to compile this, make sure we have 150, and I'm going to save this as part 2.1, and I'm just going to copy this so that we have that for the notes for today's video, so that this will be in the YouTube description at the bottom, and you can see the solution. What I'm going to do now is I'm going to keep that same input, but we're going to modify it to be for part 2.2. So we're going to do that. I'm going to change the name there. And what we're going to do is we're going to solve the new problem. So let's take a look at what we did that worked and what we did that's going to need some modification. So submarine's going to be holding on to something called aim. So we're going to need to add that here. But horizontal position stays, depth stays. And something that we did that's actually like really nice is we took these commands. So let's go back to before we did all this work. So I'm just going to comment this out here with a multi-line comment. All these commands are still correct. So all the work we did for parsing the commands and doing all this stuff, that's going to stay the same. What we're going to want to do is we're going to want to change the implementation of move submarine. So really we're just going to be changing what this does from turn to turn. So we're even going to be able to leave this body in, I think. So what I think we need to do is we're going to need to keep track of the aim. And I think the puzzle said it's initially at 0, correct? Yeah, the aim is going to also start at 0. So let me go back. I think I accidentally typed 0 here. Now this is just the integer. And then aim is going to be initialized at 0. So I'm going to rename this to be clear. I should have caught that before I saved that. Okay, cool. So I'm also going to do this to format our code a little bit. So this is the initial state of the submarine. That's good. But now horizontal position and depth are both going to change when we do this. So when we move forward, horizontal position does change by that amount, just like before. But now the depth is also going to change. So we're going to take our current submarine depth and we're going to add our submarine aim to it. So that's like a new behavior of the forward. And then all we have to do is just tweak how up and down work. So up is going to basically modify our aim by that amount instead of our depth. And I think that's it. Hopefully that'll be okay. Let's take a look and see if we get the values we expect. So it said 900, I think, was the number. We got 225. Let's see if I did something wrong. Ooh, it was amount times the aim. Sorry, that was my bad. So the puzzle said you have to do amount times the aim. Back in their example, they said 8 times 5, which would give us 40. What I was doing before was just adding 5, which is not correct. Let's see if this gives us 900. Cool. Okay, so it looks like we did that. And that part 2 seemed to go pretty quick. And I think it had to do with how we broke apart the string problem, and we have like the command work already done for us. We had like a good kind of like template, and we just use really simple functions for the whole thing. So fingers crossed. Let's see if the puzzle input. I'm gonna save this and I'll clear this out. Let's see if pasting in this puzzle input gets us an answer that we want. So this one's a lot bigger. This is 1 billion? Yeah, 568,138,742. So does it work? Easy money. Day 2. That had to be like half the time. How long has this video been going for? 20 minutes? Easy. Yeah. Day 3 is going to be a breeze. So let's take a look at what we did. The differences between the two puzzles. It was really just tweaking what we were storing in our submarine state, tweaking the initial value, and then just changing what the commands, how the commands affected the submarine. And once that was done, the puzzle kind of solved itself. The rest of our code was totally good. So I saved this. I'm going to copy this here. And today's challenge was a lot less involved. I didn't get lost and accidentally start implementing the wrong thing like I did with day 1. But let's take a look. So Advent day 2. Awesome. Okay, so we've got 4 stars. That's 4 out of 50. We're not going to do 50. It's just too hard. I'm just not that smart. But if they were all as easy as day 2, maybe we can pull it off. But yeah, so if you're curious on how to get started with this, you can go to adventofcode.com. You can like log in here. I logged in with my GitHub. And then if you go to Ellie app, you can like take these URLs. I'll have them in the video below, and you can put them in yourself, or you can try this yourself. And then of course there's like the package docs for elmling.org. All these links will be available in the video. Thanks so much for watching, and yeah, I'll see you guys next time. Take care.